Welcome everyone, this is Neil from Edureka, and in today's session we'll be looking at Informatica transformations. Let's move ahead and look at today's agenda. We'll begin the session by first understanding why do we need transformations and why it was accepted in the industry. After that, we'll look at what is a transformation, followed by the various types of transformations that are present in Informatica. Now, Informatica offers us 33 different types of transformations, but we'll mainly be concentrating on 5 of the most commonly used transformations today. The first of those is the source qualifier transformation, which is a basic transformation used to convert the data types to Informatica supported data types. After that, we have the joiner and the union transformation. Now, these transformations help you combine the data from various sources. Then we have the expression transformation. Now, the expression transformation can be used to perform or calculate certain expressions which can be applied to each row. Finally, we'll be looking at the normalizer transformation. This transformation helps us in converting the data to a normalized format. So are we clear with today's agenda, guys? So Matthew says he's clear. John says it looks promising. That's good to hear, John. Ajay says he's clear. Okay. Sham says he's good to go. All right. So now let's move ahead and start today's session by first understanding why do we need transformations. Now, to help you understand why do we need transformations, let me give you an example here. Let's say you're part of an MNC. Now, like most MNCs, you have your companies located in various countries and departments located across each state. Now, each department may use its own application to store its data, and this data needs to be validated on a regular basis to understand the performance of the company. So this is where the problem starts. Since you have to analyze the data from all these applications, it becomes a problem for you because each of these applications may use its own format or may use its own type of data to store. To put it better, let's say in the Oracle database, we have the float type, but when you look at the MySQL database, we have multiple types for floating values, that is the long float, the double, and so forth. Now, when you see as a whole, each department may in itself use different applications. So there could be an SAP database, you could have the Salesforce, you could have Oracle, and so forth. Now, once you've gathered the data from all these sources, you need to analyze this, but since they are in different formats, you cannot go ahead with this. So this is where transformation comes into picture. Using transformations, you can convert the data in these various formats to a common format. Once you have the data into a common format, the process of analysis becomes easier. Are we clear with this, guys? Okay, so John wants another example. Alright, John, can I know which domain you're in presently? So you're from the manufacturing domain. Okay, let's look at your domain itself. Now, John, let's say you cater to about 200 to 300 different vendors. Now, each of these vendors may give their requirement in different formats. Now, at the time of product delivery, once you've completed manufacturing the product, it becomes a problem for you to understand which vendor required which product at which time, because all this data are in different formats. So using transformations, you can convert this data from all these vendors to a common format and store it in your database. Now, in that database, you can always check and follow up with each vendor. Was that helpful, John? All right. So apart from converting the data from various format to a common format, there are various other operations that you can perform using transformations. Now let's say you've stored your data in an encoded format in your database. Using transformations, you can decode this data and move it across. Let's say you're processing various data and you wish to add timestamp on when the data is being processed. You can do that as well using transformations. Now, one of the major problems faced by all industries is that identification of error present in their data. Now, through transformations, you can identify if there is any error or any inconsistencies in your data. Once you've identified this, it becomes easier for you to correct it. Now, it may all look like magic to you, but trust me guys, at the end of the session, you will be able to do these operations by yourself. Now, let us look at the image here. Originally, when you were saving your data, you had chosen an unstructured format. This choice in turn led to a lot of inconsistencies, and when the time came to analyze this data, you were facing a lot of troubles. Now, through transformations, you can convert this inconsistent and unstructured data to a structured and consistent format. From here on, it's quite easier for you to analyze this data. Now, Informatica mainly operates on structured data. However, if you do have an unstructured or a semi-structured data format, you can also transform that as per your requirements. Now, are we clear on why do we need transformations? Dave says he's clear. Ajay is also clear. Matthew has understood it. So has Neha. Alright, so I assume you've all understood this, but then we all come across the question, what is a transformation? So let us look at that next. Now a transformation is basically used to represent the set of rules which define how the data is being transferred from the source to the target definition. Now in these rules you'll define what data has to be transferred, the format of the data, or let's say you wish to have only certain data, then you can specify that as well in these rules. Now let's look at the image below here. So here what we are doing is that we are extracting the data from 4 different sources. The first being an XML file where the data is in semi-structured format. After that we have the COBOL and the flat file. Finally we have a database table as well. So what we are doing here is we are extracting the data from all these 4 sources and then we are putting it in the playground of the transformation. Here you can perform all the operations that you wish on the data and change it to the format as you wish. You may select only data that meets your condition, or let's say you wish to normalize this data, you wish to convert an encoded data to a decoded format. All this can be done in this playground. Once you've performed all the operations that you wish on this data, you can then go ahead and load it into a target data warehouse. Are we clear on what is a transformation? So John says he's clear. Matthew is also clear. So Jessica has a question here. What are the common data formats? Now Jessica, the format of the data depends on what application that you're using to store this data. So it may vary from application to application. The data is always the same. It is just that the type of data will vary with respect to the application. Was that clear? Alright, so any more questions with respect to what is a transformation and why do we need it? Okay, so John says no. Matthew says clear. Okay, so I'll assume we're clear on this, and now let's move ahead and look at the various types of transformations that are present in Informatica. Now when we look at the various types of transformations in Informatica, they can be broadly classified on the basis of 2 major factors. The first factor is based on their connectivity. When we talk about connectivity, it basically means we check if the transformation is either connected to at least another transformation or the target definition. So we have the connected as well as the unconnected. If it is connected to another transformation, it's a connected transformation, but if it's not, it's an unconnected transformation. The second category is based on the change in number of rows. Here again we have 2 types. We have the active and the passive transformation. Now when we say an active transformation, you can call those transformations that change the overall number of rows that pass through it. That is, the total number of input rows may not be the same as the total number of output rows. So if you're changing the overall number of rows that pass through it, you can call it an active transformation. But in a passive transformation, it always remains constant. It's just slight variation with respect to the data in these rows. Any questions about these types? Okay, so Matthew wants to know what is use of a passive transformation if it is not changing the number of rows. So Matthew, I'd request you give me some time. We will be talking about the passive transformation in the slides ahead. So please be patient. Now before we move ahead and look at the types of transformations, there is one thing that I'd like to put across. Now every transformation belongs to at least one of the 2 types from each category. That is, a transformation could be a connected and an active, it could be a connected and passive, unconnected and active, unconnected and passive. Now this is classified on their basis of usage. So this is important that you remember. It's mainly based on their usage that the transformations are classified. So Janice has a question here. So Janice is asking us, is it possible for a transformation to be connected and active and connected and passive as well? Yes, Janice. Here let me give you the example of the lookup transformation. Now the lookup transformation by default is a passive transformation. However, while you are creating it, you can make it an active transformation as well. And based on your needs, you may either connect it or you may keep it as unconnected as well. Does that answer your question, Janice? Alright, so any more questions with respect to these types of transformations? Okay, so let's move ahead and look at the first category of transformations based on their connectivity. So here, as we have discussed, we have 2 types. The first is a connected transformation where the transformation is either connected to another transformation or directly to the target definition. An unconnected transformation, although is not connected to another transformation, is still part of our mapping. Now when I refer to a mapping, it is basically the iconic representation of each of either the source or the transformation or the target definition. So here is an example of a connected transformation. So here we are extracting the data from the source, passing it through transformations and then storing it into the target. Similarly, if you look at the unconnected transformation, here we have a pipeline and the unconnected lookup is not part of this pipeline. A pipeline basically is the connection from the source through the transformations to the target. So as you can see, the unconnected lookup is not part of our pipeline. However, it is part of our mapping because it is being remotely called in the expression transformation. Are we clear on the two types based on their connectivity? Janice says yes. So Dave has a question here. Why do we use unconnected transformations? So that's a really good question, Dave. Unconnected transformations are mainly used when we need specific data that meets a condition. Let's say while you're looking up the details of all the employees, you just wish to understand the salary of the employees who are working under a specific manager. So in that case, you can use the unconnected lookup transformation and extract the details of those employees under that manager. Was that clear, Dave? Alright. So now let's move ahead and look at the second category of transformations. So here we have the active and passive transformation. Now in an active transformation, the number of rows that pass through the transformation changes, or we change the transactional boundary or the row type. The transactional boundary comes into picture when we are processing transactional data, and the row type attribute is something that defines how each row is present in that table. To give you a better understanding, let's look at the example here. Now here we have an active transformation. Let's say it's a filter transformation. You're passing in 3 rows, but you're getting only 2 rows as output. So the overall number of rows, that is the total number of input rows, is not same as the total number of output rows. But when we look at a passive transformation, we are passing in 3 rows, we are getting 3 rows as output. It's just that the format of this data present in each row has been changed. So coming back to your question, Matthew, does this answer your question? Why do we use passive transformations? Alright. Now to give you examples of active transformation, let's say the source qualifier transformation, the aggregator transformation, the expression transformations are some of the most widely used active transformation. So Dave wants me to repeat passive transformation. Now in a passive transformation, the number of rows that pass through it is constant. So here you can see we are passing in 3 rows, but we're getting 3 rows as output. It is just that the format of the data in this row. So here you can see there are parentheses and hyphens separating the region code, but when you see as the output, there are no special characters present here. Is it clear now, Dave? Alright. So moving ahead, let us look at some of the commonly used transformations in Informatica. So here we have list of 11 transformations that are active and connected transformations. Don't worry, we'll be looking at some of the passive transformations as well. So we'll start off by first looking at the aggregator transformation. Now the aggregator transformation is mainly used to perform aggregator functions. Let's say you wish to find the sum of the overall money that you need to pay, or let's say you wish to find the maximum that you're paying each employee, you can use an aggregator function here. After that we have the source qualifier transformation. Now the source qualifier transformation is a basic transformation. It helps us in converting the data types that are present in the source to the data types that are supported by Informatica. It is something that gets automatically created if your source is either a relational table or a flat file. Don't worry, we'll be looking more into the source qualifier in the slides ahead. Then we have the joiner and the union transformation. Now these transformations helps us in joining the data from various sources. The only difference being, using the joiner transformations, we can join only 2 sources, but as long as they have at least one matching column, you can join them. But in the union transformation, we can join n number of sources, but they need to have same column names, same data types with the same precision. Only then can you join the multiple sources. Following that, we have the normalizer transformation. Now the normalizer transformation helps us in converting the data to a normalized format. Let's say you have a customer database in which each customer has about 3 addresses. Using a normalizer transformation, you can make sure that each customer has only one unique address associated with it, but you'll have the repeated details of the customer present. After that is the rank transformation. Now using the rank transformation, we can extract a certain range of values from either the top of the table or from the bottom of the table. Now this range can be set by you. Let's say you wish to extract the top most sold products, top 10, top 50 most sold products. You can do that by using the rank transformation. Then there's the router transformation. Now the main aim of router transformation is to group the data that comes to it and then pass it on to other transformations. So let's say you have 100 rows, you can group them as per odd and even and then pass each of these groups to different transformations. Next is the sorter transformation. Now as the name suggests, sorter transformation helps you in sorting the data either in an ascending or a descending manner. Following which is the filter transformation. So the filter transformation filters the data that passes through it which does not meet a specific condition. Let's say you wish to extract only distinct rows from the data that is being passed through it, you can use a filter transformation. Then we have the transactional control transformation. So the transactional control transformation is mainly used while we are processing transaction data, and it is used to control the commit and the rollback operation. Now when you do this, you're automatically changing the transactional boundary, so therefore it is an active transformation. Finally, in this list we have the update strategy transformation. Now the update strategy transformation sets a flag across each row that helps the integration service understand if the row has to be either inserted, deleted, updated or rejected while it's processing it. Are we clear on these 11 transformations? So Ajay has a question here, shouldn't sorter transformation be a passive transformation? Now Ajay, once you're setting a condition based on which the data is being processed or sorted, if a data does not meet this condition, let's say you've specified that it be sorted as per a specific column value, then if that column value is not present, the row is rejected. Are you clear? Alright. Or let's say another example with respect to the sorter transformation, make sure only distinct values are being sorted. You can specify that as well in the sorter transformation. Okay, so now let's move ahead and look at some of the passive transformations. So we'll start off by looking at the expression transformation. Now as I have mentioned, the expression transformation is a passive transformation and it's mainly used to compute certain expressional formulas. So let's say you wish to concatenate the first name and the last name of your employee, you can do that in an expression transformation. After that we have the sequence generator transformation. So the sequence generator transformation is mainly used to add a key value across each row. This comes into handy when you do not have a primary key in your target table. So you can generate a key sequence value for each row and declare that column to be a primary key. Now here we have the lookup transformation. Now the lookup transformation, as you can see, can be used in all 4 modes. By default, as I had mentioned earlier, it's a passive transformation, but you can also create it as an active transformation. So in the previous example, you've seen how a lookup is being used in unconnected mode. You can similarly use it in a connected mode as well. So the main use of a lookup transformation is to look up a certain value from a relational table or a flat file that is present externally, or if you wish, you can look it up from your existing set of sources, your source qualifier or your target definition as well. So Janice, coming back to your question, is this helpful? Alright. So now in case if you are processing XML data, that is if your source file is either XML file or if you're generating an XML file through the pipeline, you'll be using the next 3 transformations. Now the XML source qualifier transformation is similar to the source qualifier transformation, just that it is associated to an XML file. Then we have the XML generator and the XML parser. If you wish to generate an XML file in your pipeline, you'll be using the XML generator, and if you wish to extract the details of an XML file, you'll be making use of the XML parser transformation. Now finally in this list we have the external procedure transformation. This is a favorite of most developers. So this comes into handy when you need to perform complex calculation. Now you can make use of various expression and aggregator transformations to do this, or what you can do is you can already write a procedure in an external shared library or a dynamic library and call it remotely in the external procedure transformation. So are we clear with these 7 transformations as well? John says he's clear, Dave is also clear, Janice is also clear, Ajay says he's understood. Alright. So to summarize what we've learned till here, we've understood why do we need transformations, we've looked at what is a transformation, the various types of transformation and some of the commonly used transformation. It's time we deep dive into these transformations, and we'll begin that by looking at the source qualifier transformation. Now the source qualifier transformation is a default transformation that gets created if your source is either a relational table or a flat file. You do not need to explicitly create a transformation if your sources belongs to either a relational table or if it's a flat file. Now the reason a source qualifier transformation is considered to be an active transformation is because using a source qualifier transformation, you can define how the data is being fetched from the source. So to give you a better understanding, let's say you wish to have the data only that meets a certain condition. So all that you need to do is that you need to write an SQL query and then place it inside the SQL query field inside the source qualifier transformation. This image is the properties tab of the source qualifier transformation. So here all you need to do is specify the SQL query. Now another operation that you can do using the source qualifier transformation is to extract the data that is distinct. So all you need to do is just make sure you have checked the select distinct option, so only distinct values will be loaded from the source. Now we're going to see a key feature of the source qualifier transformations ahead. What we're going to be using the source qualifier is for joining two tables that are already present in a database using a common link between them. Don't worry, you'll understand it better when we look at the use case. So here, let's say you're part of an organization. Now your departments are located in various locations, so you need to provide your employees a department-wise transportation. Although your employee table has the details of the department ID, you still don't know the location of that department or the department name. This data is present in another department table. So what we're going to do is that we're going to join the details of the employee and their corresponding department details from the department table and the employee table. To do this, we'll be making use of the source qualifier transformation. So let's begin by creating a new work folder. To do that, you need to launch the Informatica Power Center Repository Manager. One thing, if you're making use of the Oracle version of Informatica, please make sure the Informatica services have been started and they are occupying about 400 MB of your RAM. So now let's go ahead and launch the Informatica Power Center Repository Manager. To do that, click on the Start icon and go to the Informatica folder present there. Now if you're making use of a Windows version earlier than 10, you can find the Power Center Repository Manager inside the client folder. If you're using Windows 10, you can find it directly present here. So click on it and it will launch the Informatica Power Center Repository Manager. Now if you've had any troubles while installing Informatica Power Center or while configuring the Repository Manager, you can check out our blog Informatica Installation in 9 Easy Steps. So here select the repository that you have configured and click on the connect icon to connect to the repository. You will get a pop-up asking for your username and password for the repository. So specify that and click on the option to connect to it. So now we'll begin by creating a new work folder. Now the aim of creating a new work folder is so that we can store all the sources, the targets, the mapping and the workflow that we'll be creating in today's session in a single place. This comes into help when you're working on various processes using Informatica. Now to create a new work folder, go to the Folders tab and select on the Create option. Here you can specify the name of the work folder that you wish to set. Please make sure you do not make use of white spaces because Informatica does not support spaces in its naming convention. Click on OK to create the new work folder. And now we can go ahead and begin with the designing process. Now to design the mapping, we need to launch another product of Informatica Power Center, that is the Informatica Power Center Designer. To do that, all you need to do is click on the D icon present here and automatically the Informatica Power Center Designer will be launched. So now once you're here, select on the work folder in which you wish to create your mapping. So right click on the work folder, connect to it and click on Open to open the workspace. Now the first stage of designing is to load the sources. So I have already mentioned to you my tables are present in a common database. So let me go ahead and show you how you can load the sources from a database. To do that, make sure you're in the Source Analyzer workspace, click on the Sources tab and select Import from Database option. Here you need to select the connection object to your database. Now if you have not configured the connection object, click on the dots and here you can go ahead and add the connection object. So let me select the connection object and then specify the username and password to the database. Click on Connect to connect to the database, and once you've connected to your database, you can see the username. Now inside the username you can see all the tables and the views the user has access to. So here I want the department and the employees table, so select them and click on OK to load these sources. Now as I have discussed earlier, there's already a primary key foreign key relationship present between the employees and departments table. We're going to be using this constraint to join these two tables. So to begin your mapping, go to the Mapping Designer workspace. That's the last icon present here. Here you need to bring in the sources that we have just loaded. You can find them inside the sources folder. Just select the sources, drag it and drop it to the workspace. Now automatically it will ask you the name of the mapping that you wish to set. By convention, all mappings begin with a prefix M followed by the name that you wish to set. So Dave has a question here, what is a connection object? Now the connection object helps you in connecting the Informatica Power Center to your database. So using this you will be connecting to your database. Are you clear, Dave? Alright. So once you've specified the name of the mapping, click on OK to create the mapping. So here you can see we have only selected 2 sources, but there are 4 icons present here. Now for each source there's a corresponding source qualifier transformation created. Let me arrange this for your better viewing. So as you can see, for each of the source definitions there's a corresponding source qualifier transformation that was automatically created. Now I had mentioned to you earlier, the main objective of a source qualifier transformation is to help you convert the source data type to the data type supported by Informatica. So if you see the source definition, we are making use of a number which has a precision and a scale set. But when it comes to an Informatica data types, it is being converted to a decimal value. So to move ahead, we need to join both these source definitions. For that, we need only one source qualifier. So what I'm going to do is that I'm going to delete the source qualifier for the departments table. Just select the source qualifier and press on the delete option. So now what we need to do is that we need to select the columns that we wish from the department table and place it across into the source qualifier. So we need the department's ID, we need the department name and the location ID. So once you've selected it, drag it and drop it to the source qualifier. Now you can see automatically these columns have been added to the source qualifier and they've also been linked to the source definition. Now to move ahead with our mapping, we need to create a target definition. Now there are 2 ways to create a target definition. One, you can manually create a target definition where you have to define each column, its data type and its precision, or you can model a target table on the basis of a transformation. So here what I'm going to do is that I'm going to create a target definition on the basis of the source qualifier transformation. To do that, all you need to do is right click the source qualifier transformation and click on the create and add target option. So you can see we have just created a target definition that is same as the source qualifier transformation. Now we cannot go ahead with our mapping because the target definition needs to be updated. As you can see, we have 2 department IDs, so this needs to be removed. To do this, you need to go to the target designer workspace, that is the second icon present here. Click on it. So as you can see, we have an empty workspace. Inside the target folder, you can find the target definition that we have just created. Just select it, drag it and drop it to the workspace. Here, to make any changes to the target definition, just double click on the target definition and you can see an edit option come up. Now by convention, it is suggested that you name your target definition with a prefix of TGT because it helps you in differentiating the target definition. So let me just rename this target definition and click on OK to rename it. So now let's change the columns present in this target definition. Go to the columns tab and here you can find we have 2 department IDs. So just select one of the department IDs and remove it. Now with this, we've completed the updating of the target definition. So click on apply to apply these changes and OK. So now let's go back to our mapping designer workspace, remove the target definition that we had created earlier and load the updated target definition. So just select the updated target definition and drop it to the workspace. So any questions still here about the source qualifier transformation or how to create a target definition? So Dave is asking us what is a target definition. Now a target definition is an abstract format on how you wish to have your target tables. So based on the same schema, we'll have our target table present. Are you clear, Dave? Okay. So Sandeep is asking us, won't it be a problem if we have 2 department IDs present in the source qualifier? So Sandeep, there has to be 2 department IDs present in the source qualifier because we're going to use these 2 department IDs and join the 2 sources. I'll show you how it's done. So just double click on the source qualifier transformation. Now here you need to specify the condition through which you're going to join the department IDs. So go to the properties tab and here inside the user defined join, just click on the arrow mark that is present. Now as you can see, we have 2 department IDs from the different tables. So what we need to do is that we need to specify that these tables have to be joined on the basis of department ID. So first double click on the department IDs from the department table. To join, we use an equal operator and then double click on the department ID from the employee table. So once you've done with this, click on OK. So you may still be fuzzy about this. So let me show you the SQL command based on this condition that we have specified. Now before we go ahead and create the SQL query, this will not successfully be created if you've not completed your mapping. So make sure you have completed your mapping. So let's go back and complete the mapping. Click on apply, click on OK. And what we need to do is that we need to link the source qualifier to the target definition. Now there are two ways to link the source qualifier to the target definition. The first is to manually select the rows, drag it and drop it to the target definition, and the second is to make use of the auto link feature provided to us by Informatica. Just right click on the workspace and select auto link option. So here you can see the start for the link option and the end for the link option. Now there are two ways you can link them. You can either link them by name, that is you'll be comparing the names of each column present in the start point to the end point, or you can link them by the position number would be mapped. So if you click on apply now, you can see automatically the link has been established as per the names. So now let's come back to the source qualifier transformation. Here inside the properties tab, let me show you the SQL query through which you will be joining these two tables. So inside the arrow mark, just click, you'll get the SQL editor option. Here just click on generate SQL and you can see an SQL command has been generated to join these two tables. So you can see the where condition present here, where department.department ID is equal to employee.department ID. So we're going to be using both the department IDs here to join all the data. Was that clear, Sandeep? Alright. Now as I had mentioned, if you wish to select only certain data that meets a condition, you need to write the SQL query for that condition. Now a key feature that Informatica provides us is to validate if the SQL query that you have written is correct or not. You can compare this SQL query to your source data. To do that, what you need to do is select the corresponding source object, specify the username and password for the database, and then click on validate option. So what you're doing is that you're executing the SQL query on the source data here. Click on OK to complete this and click on apply to apply these changes. So once you're done with this, save the mapping, just press Ctrl S and Informatica will save the mapping as well as it will check if your mapping is valid or not. Now if you notice in the output window, you can see Informatica has checked whether my mapping is valid or not, and in case if your mapping is not valid or if there are certain disturbances with the data type transmissions, then it will inform you about this. Now before we go ahead with this, is there any question still here? John says no, Ajay says no, Dave is clear. Alright. So till here what we've done is we've set the set of rules through which the data is going to be transferred. Now we need to move ahead with the process through which the data will be transferred from the source to the target definition. To do that, we need to go ahead and create a workflow on executing of which the data will be transferred. Now there are two ways of creating a workflow. You can either manually create a workflow or you can create a workflow automatically using the generate workflow option present. Now in case if you wish to make use of multiple mappings in your workflow, then it's suggested that you manually create this workflow. Else if you wish to create a workflow for a simple mapping, you can go ahead and create the automatic workflow. So right click on the workspace and select generate workflow option. Here only if you're making use of reusable sessions. Now sessions are option present in your workflow which can be reused across different workflows. So since we are not going to be using reusable sessions, just click on next. So here you can see the various connection objects. Click on next. You can see the workflow settings and finally click on finish to complete the workflow. Now with this we have completed designing a workflow. We need to go ahead and set the session properties and execute it. But before we do all that, we need to first go back to our target definition and create a target table in which we're going to store this data. At present we have just defined how the target table should be, so we need to create a target table. So go back to the target designer workspace. Here in the targets tab you can find the last option, generate execute SQL. So click on it and you'll get a new tab. Here since you are going to be creating a new table, make sure the create table option is checked. Once you've set that, just click on generate and execute SQL. Now you'll be prompted asking to select the connection object to your target database. So make sure you have selected the object to the target database and then specify the username and password for the target database. Now once you click on connect, a connection would be established to the target database and an SQL command would run to create the table that we have just designed. So here in the output window you can see an SQL that is create table tgt underscore sq underscore employees with the same definition that we have set has been executed. Are we clear till here? Any questions? John says he's clear. Alright, so Matthew has a question here. What happens if we do not create a target table? Then Matthew, your workflow would fail and the data would not be transferred. So while you are executing the workflow, you'll get an error telling that the target table is not present. Alright, so I've got a confirmation from everyone. So now it's time we go to the workflow manager and modify the workflow that we have just generated. Now to launch the Informatica workflow manager, just click on the W icon that is present here. Now to find the workflow that we have just created, go to the work folder under which you can find the workflow folder, and there you can find the workflow that has been created. So select it and right click, choose the open option, and you can see the workflow that was generated. Now here, before we go ahead and execute the workflow, we need to set certain values for the target table. So just click on the session icon and you'll get the session properties. So here go to the mappings tab and you can see the details of the source as well as the target. Now one thing, always make sure you have verified that the correct connection object is being used for reading as well as writing. Now the connection object used for reading is Oracle HR_SRC, but as you can see, the same has been set for writing. Since it is going to be written into a different table, make sure you have selected the correct connection object. Once you've made the required changes to the target details as well as the source details, click on apply and then go ahead and save the workflow. So Janice is asking us, can there be more than one connection object? So Janice, are you asking if you can choose more than one connection object to save the same target definition? No, Janice. So if you wish to save the target table into various databases, you need to create different target definitions, or what you can do is that you can create different sessions to store each of the target definition into different targets. So are you clear? Alright. So one thing to notice here, guys, again when you save the workflow, Informatica checks if your workflow is also valid, and as you can see in the output, it is valid. So at times what happens is, after you have created a workflow, you may go back to your mapping and perform certain changes. So in that cases, you may find an error with respect to the session properties. So you need to make sure you have saved it every time before you go ahead and execute the workflow. Now going ahead to execute the workflow, there are two options. You can either go to the workflow tab and select start workflow option from here, or you can right click on the workspace and select start workflow option. Now when you click on start workflow option, automatically the Informatica Power Center workflow monitor launches. Now the workflow monitor helps you understand the progress of the workflow that you have designed. So you can see the corresponding workflow, its session and its progress. Now if you wish to understand better how the workflow has been executed, just double click on the session icon and you will get the run properties. Now here, if you wish to understand how many rows has been transferred from the source or the target, or if you wish to get a statistics with respect to the source and target, just go to the source target statistics and here you can see the details. Now since I am making use of only one source and one target definition, I have just two rows. Now I have 106 rows present in my source, on which all the 106 rows have been affected by the transformation. These rows then have gone to be stored in the target definition. So let me show you how these tables look in the target database. So just launch the database application that you're using and check the tables. So here you can see, apart from the employee details that was already present, there are new columns that are the department name as well as the location ID. Let me also show you how the source table looks like. Now as you can see, when comparison to the source table, we have two new columns present in our target tables. That is the department name and the location ID. Any questions still here about executing the workflow or making use of the workflow manager? So Dave says no, Matthew says no, Sandeep says no. Alright, Ajay says no. Now to summarize our understanding of the source qualifier transformations, I've just shown you how you can join sources present in the same database using the source qualifier transformation. Now you can join multiple sources as long as they have a relationship present between them through which you can link them. Now apart from that, I've also mentioned how you can select distinct values from the sources, and you can also set a custom query based on which only selected data will be extracted from the source qualifier transformation. Any questions with respect to source qualifier transformation? So Janice says no, Ajay says no, Dave says no, Sandeep says no. Alright. Now using the source qualifier, we have joined two tables that are present in the same database. Let me show you how you can join two sources present in two different file formats, and we're going to do this using the joiner transformation. Now in the joiner transformation, you can join only two sources, but they need to have at least one matching column present between them. When I say one matching column, they need to have the same column name, they need to have same column type, and finally they need to have the same precision as well. Now for Informatica to differentiate between these two sources, one source is called the master source and the other is called the detail source. The reason to do this is because the master source table is always cached, which makes it easier for it to join the two tables. But if you wish, you can change and set whichever table you wish as master. Any questions about the joiner transformation? Ajay says no, Sandeep says no, Matthew says no, Dave says no. Alright. So now in the image you can see how we are joining the master source and the detail source through a joiner transformation, where we have specified the join condition to be master.customer_id equal to detail.customer_id. We've set a similar condition in the previous source qualifier transformation as well. So once you've specified this condition, you can use the joiner transformation to get a joined result. So John has a question here, are we joining two databases or two tables? So John, we're joining two tables that are present in two different databases, or it could be one is present in a database, the second is present in a file, and so forth. Basically, we're joining tables present in two different types of sources. Are we clear? Alright. So Dave is asking us, what do I mean I should have one column to be common? So again, Dave, when I say it needs to have at least one column to be common, that is in the schema of both these tables, there needs to be at least one column which has the same name, the same data type, and the same precision. Now these data types can be similar, but the overall data types should be same while you're converting it into Informatica data types. Don't worry, you do not need to convert this. Informatica will automatically convert them. Are we clear, Dave? Alright. So using the joiner transformations, there are four types of join that we can process. Now the first type is a normal join. So here what we're doing is that we're just selecting the common details that are present between the master source as well as the detail source. So once you've specified the condition through which it is joined, only those rows that match this condition would be selected. However, if you're using the master outer join, all the rows present in the detail source will be selected, but only those rows that meet the condition from the master will be selected. Then we have the detail outer join, which is a complete opposite of the master outer join, where all the rows from the master source will be selected and only those rows that meet the condition from the detail source is selected. Finally, there is the full outer join, through which you can join all the rows present in both the master and the detail source. Any questions on these types of joins? So Matthew has a question here. Matthew is asking us when should we use which type of join. So Matthew, this depends on how you want your target data to be. That is the output data from the joiner transformation, how you wish to have it. Based on that, you will specify the type of join. So let's say you wish to have only those rows that meet the condition from both the master and the detail, you select a normal join. You get the idea. Alright. Any more questions? Dave says no. Alright. Now to give you guys a better understanding of how the joiner transformation works, let's look at a use case. So here let's say you're part of a retail organization. Now you have your details of your customer present in a flat file and the details of the product that you sell present in a database. But now you wish to understand the complete details of the transaction. That is, you wish to have the details of the customer and the complete details of the product that they have purchased. So using a joiner transformation, we're going to join the details of the customer with the details of the product. Let me show you how it's done. Let's go back to the Informatica Power Center Designer. Here, let's begin by creating a new mapping. So select on the mapping tab and click on create. Now once you've created a new mapping, it's time we load our sources. To do that, go back to the source analyzer workspace. Here you may find the source definitions that you have used earlier, so make sure you clear them. Right click on the workspace and select clear all. So now, as I have mentioned, my product table is present in a database and my customer details is present in a flat file. So let me begin by first loading the products table. So click on sources and select import from database. Here you need to set the corresponding connection object and the username password. Once you specified that, click on connect to the database. Now inside the tables, let me select the products table and click on OK to load it. Now I need to load my customer details. To do that, go to the sources option and select import from file option. Now one thing to be kept in mind is that you need to always remember the path in which your source file is present. Now by default, Informatica searches your source file to be present inside its installation folder. Let me show you the exact path. So it's inside Informatica, the version that you have installed. Then inside server, you can find the infra_shared, and there it will search inside the sources file folder. So if in case your source file is not present in this location. Please make sure you remember this because you need to change this before you execute the workflow. Now I need to select my source file, so select it and click on OK. Now since my source file is a flat file, Informatica gives me a flat file wizard through which I can import this data. Here let's say you're not using a delimiter to separate your fields but a fixed width, then you can select a fixed width option also. Now one thing to be kept in mind is that if your first row contains field name, make sure you have checked import field names from the first line option. Because if you do not do this, the field names for the corresponding values will not be set. Now click on next. Here if you're using any different delimiter apart from comma, you can specify that, and if you're using text qualifier, you can specify that as well. So since I'm not making use of either, click on next, and here you can see the column names that will be present in my source once I've completed the import. So for each source you can see the name, the corresponding type, that is we have text, numeric or date time, and then you can see the corresponding length or precision, the scale and the width that has been allocated. Now this is automatically allocated by Informatica after it has read a set of values. So if you wish to change this, you can always specify the value that you wish. So all you need to do is specify the value here. Let's say for last name I wish to provide 12, so just set it as 12 and click on finish. Any questions on how to load a flat file? Sandeep says no, Dave says no, Janice says no. Alright, so let's go ahead and begin with our designing process. So go back to the mapping designer workspace and then load the sources that we have just added. So the flat file will be under the flat file folder. Here select the source and drag and drop it. Similarly drag and drop the products table. Now one thing to be kept in mind guys, so here as you can see we are loading two different types of sources. One is a relational table, that is the products, and the second is a flat file. But for both of them a corresponding source qualifier transformation has been created. So this goes back to the same definition that I had mentioned. By default, if your source table is either a relational table or a flat file, then Informatica automatically creates a source qualifier for these sources. So now that we have loaded these sources, it's time we create a joiner transformation. Now you can do that in two ways. First, you can go to the joiner transformation icon present here, or you can go to the transformations tab and click on create option. So here from the drop down menu, just select the joiner transformation and set a name for this joiner transformation. Click on create and we are done. So now since I wish to have all the values from both my customer and product table, just right click on the source qualifier and choose select all option. Once you've selected all, drag and drop it to the joiner transformation, and you can see these fields have been correspondingly added and they have been linked to the sources. Similarly do the same for the product table, select all and drag and drop. Now as you are aware, to complete our mapping we need to create a target definition, so right click on the joiner transformation and create and go to the create and add target option. Now similarly like we had edited earlier, we need to edit this target definition as well because we have two product ID present here. So let's go back to the target designer workspace. Here clear all the existing target definitions, drag and drop the target definition that we have just created. Now one thing guys, if you are creating a target definition based on a transformation, the target definition will also get the same name. So make sure you have renamed it as well. So double click on the target name, here select rename option and we've renamed it. So now we need to remove the two product ID that is present. So go to the columns tab and here select one of the product ID and remove it. Click on apply and we are done. So John has a question here, can we create a target file to be a flat file? Sure John, a good question asked at the right time. So double click on the target definition and here in the first tables tab you can see we have a last option, that is the database type. So based on this option the target table would be created. Now if you wish to create a flat file, just select here and go to the flat file option. Now once you've clicked it as flat file, you can see automatically a new option has been set below, that is the flat file information. Here if you wish to create a flat file with either fixed width or delimiter, you can set accordingly. If you wish to set any special character as delimiter, click on advanced and here you can specify the column delimiter. So click on apply and click on OK. Now it's time we go back to our mapping designer workspace. Here remove the existing target definition and then load the updated target definition. Same as earlier, we need to link the joiner transformation to the target definition to complete the mapping. So let's use the auto-link option. Right click on the workspace and select auto-link option. Click on apply and we've connected the transformations. So now to complete with our mapping, what we need to do is that we need to specify the condition through which the join would be happening. To do that, go into the joiner transformation, just double click on it. Now one thing I'd like to bring to your highlight is that inside every transformations apart from the source qualifier transformation, we have an option that is make reusable. Now by selecting the make reusable transformations, you can use a same transformations across different mappings. But be aware guys, once you click on make reusable option, it prompts you whether you wish to make it reusable, because this cannot be reversed. So only if you're using the same transformations across different mapping, you make it a reusable transformation. If you make it a reusable transformations, you can find it inside the transformations folder. Coming back, if you see the ports tab present here, you have all the column IDs present for the joiner transformation, and we have 3 ports present here. The first is the input port, the second is the output port, and the third port is for the master port. Now if a master port has been checked for a corresponding column, it means that this port is coming from a master. So let's say you wish to, now by default Informatica has chosen the products table to be master, but if you wish to make the customer table to be master, all you need to do is just click on the master option for any of the column from the customer table, and all the columns for the customer table will be set as master ports. Any questions about the master port? So Sandeep is asking what is use of the master port. Again Sandeep, the master port denotes that the table from which this column is coming is the master table. Now the master table is cached for easier operations, so usually it is recommended that you use a table with less number of rows, but again it's your choice. If you wish to set any table as master, you can change it by selecting it as master port. Are you clear Sandeep? Alright, so now let's move ahead and specify the condition through which we're going to join these two tables. To do that, go to the condition tab. Here you can see we have 3 columns already present. The first is the master, the second is the operator, and the third is the detail. Now to give you a better understanding, let me specify a condition. Just click on add a new condition, and you can see we have all the ports present in the master table under master column, and all the ports present in the product table in the detailed column. So here just specify the condition through which you're going to join the master and the product table. So since I'm going to join the master and the product table over the product ID, so let me just select the product ID. So as you can see, the product ID from the master table is equal to the product ID from the detail table. So Matthew has a question here, can we specify more than one condition? Definitely Matthew. So let's say if you wish to have a data that meets multiple conditions only to be extracted from the joiner transformation, you can specify multiple conditions as well. So make sure the corresponding matching columns are present in both the tables. So Dave is asking what is the difference between joiner transformation and source qualifier transformation. So Dave, using a source qualifier transformations, you can join 2 tables present in the same database. Now this is an additional feature of the source qualifier transformation, but it's mainly used to translate the data from the original source type to Informatica data types. But the joiner transformation helps you join the data present in either the same database, or if it's present in different database, if it's present in different files, if you have one in a source, if you have one in a file and the second in a database. So using a joiner transformation, you can join these 2 sources. Are you clear Dave? Alright. So Dave, the difference between a source qualifier and a joiner transformation is that using a source qualifier transformations, you can join 2 tables that are present in the same source, but you need to make sure they have a relationship present between these 2 sources. However, if you're using a joiner transformations, you can join 2 sources. Let's say you have one table present in a file and the other present in a database like we've seen here, or let's say it's present in 2 different databases, or let's say if it's present in the same database as well, you can join them using the joiner transformation. Are you clear now Dave? Alright, so now that we have specified the condition through which we're going to join these 2 tables, click on apply to add this condition and click on OK. So with that we have completed our mapping. So now let's go ahead and save this mapping. Just press Ctrl S and you can see the mapping is saved. Also Informatica has checked whether the mapping is valid or not. Now it's time we move on to the next step, that is the creation of the workflow. To do that, just right click on the workspace and select generate workflow option. Here again, since we're not going to be using reusable sessions, just click on next. You can see the connection object for the products table. You can see that since we're loading the customer table from a source file, the file name has been specified as the connection object. Similarly, for the products table also, the corresponding name for the product file has been specified. Now one thing to remember is that always when you're automatically generating a workflow, Informatica makes sure that the prefix for the workflow is WF and for the session icon to be S. But if you wish to change this, you can always change it here. So now let's go ahead, click on next. Since we're not going to change anything with respect to the workflow settings, click on next and we are done. So now it's time we move back to the workflow manager. Here you need to either disconnect to your work folder and reconnect, or you have to relaunch the Informatica workflow manager. So I'd suggest if you're working on a flow, you just disconnect to your work folder and then reconnect to it. Now inside the workflow, you can find the updated workflow that we have just created. First we need to connect to it. So open the work folder and then you can open the workflow as well. So select on open and here you have the workflow. So guys, please make sure you're paying some attention here, because if you've not stored your source file in the default directory, you need to concentrate here. I'll help you understand what changes you need to make. So go into the session properties, double click on it, and here in the mapping option, you can see, now if you look at the sources present here, we are making use of various types of reader. The first, for the customer table, we're using a file reader, and for the second, we are making use of a relational reader. So we have multiple types of reader. Since the customer details is present in a flat file, we are making use of a file reader, and since the product details is present in a relational table, we are making use of a relational reader. Now coming back, if you look at the customer table, now one change that you need to make if your customer table is not present in the default directory is that you need to specify the file directory in which the customer file is present. So make sure you specify the right path, because if you've not, Informatica cannot load the details from this file. Similarly, if you are creating a flat file as an output, in the target properties there are two things that you have to change. Now the first thing is that you need to make sure a header has been added for each of the rows, each of the columns. Now Informatica by default does not create any header. We need to manually choose output field names to be the headers. Now apart from that, Informatica by default creates an output file to be .out. So since we need a CSV file, that is a comma separated flat file, we need to change the file extension as well. So with this, click on apply and click on OK. So go ahead and save the workflow that we have just updated, and then let's execute this workflow. Right click on the workspace and select start workflow option. So here you can see the workflow has been successfully executed, and if you go into the run properties of the session icon, you can see we had 500 rows present in our customer table, and then we had 150 present in our products table. In our final table, we have only 500, where we have all the details of the customer along with the corresponding details of the product. Let me show you how the product file looks like. Now again, Informatica by default creates the target file in the target files directory present inside. So here once you go inside, you can see the target file is present here. So you can see here we have the details of the customer, and then we have the corresponding product that they have purchased, the name of the product company, and the corresponding details of the product as well. So we've successfully joined the details of the customer along with the details of the product that they have just purchased. Any questions with respect to the joiner transformation? Sandeep says no, Dave says no, Matthew says no, Ajay says no. Alright. So now let's summarize what we've learned about the joiner transformation. Now in the joiner transformation, we can join two sources. They need to have at least one matching column present between them. So if you have more than one matching column, you can set multiple conditions as well. So one thing, let me show you how you can specify the different types of join. Now if you go into the Informatica Power Center Designer, inside the joiner transformations, if you go to the properties tab, you can see the join type to be specified. Here by default it sets it to be normal join, but if you wish to specify any other type of join, you can choose it here. And we've also seen how you can set a table to be master and how you can switch it by changing the import option. Any questions with respect to the joiner transformation? Jessica says no, Piyush says no, Sandeep says no. Alright. So now using the joiner transformations, we have seen how you can join two sources as long as they have at least one matching columns. The next transformation will help you join multiple sources, but they need to have completely matching columns with the same data type and same precision. This transformation is the union transformation. Now the union transformation is quite similar to the union all command that you execute in the SQL. Here again you can join multiple sources, but one thing to be kept in mind is that while you're joining these sources, if you have duplicate records, they will not be removed after the transformation is done. Again, the main key constraint here is that all the columns need to have the same name, they need to have the same precision, and they need to have the same data type. Now at times it happens that they may not have the perfectly same precision, so make sure you have set the maximum precision as well so that they match up. So John has a question here, how can we remove duplicates with using union transformation? Now John, in union transformation you cannot remove duplicates. However, if you specify another filter transformation, or if you say, if you make use of a sorter transformation or an aggregator transformation, you can make sure only distinct values are transmitted further. Alright, any more questions? John says no, Matthew says no, Sandeep says no. Alright, so now to give you a better understanding of how the union transformation works, let's look at a use case. Now it's common that a huge organization has branches located in different vicinities. Now each of these branches will have its own set of employee details. So what we need to do is that we need to establish a global employee database. To do this, we're going to be using the union transformation. We'll be taking the details of the employees from 3 different sites, and we'll use the union transformation to join these details. Let me show you how it's done. Let me come again. So let's say as an organization you have your branches located in different parts. Now each of these branch has its own set of employee details. So what you need to do is that you need to combine the details of the employees from these different branches to a common database so that you can have a global employee database. To do this, we're going to be using the union transformation. Let me show you how it's done. Go back to the Informatica Power Center Designer, and we need to create a new mapping. Let's set the name of the mapping and click on OK. So now it's time we load the details of the employees from the various sites. Go to the source analyzer. Here clear all the existing source definitions present. Now what I have done is that I have stored the details of the employees in 3 different sites in 3 different flat files. So you need to manually load each of the flat file, as Informatica does not support multiple flat file loading. So just click on sources and select import from file. Here you can see I have 3 files, that is employee site 1, employee site 2 and employee site 3. Now as I had mentioned, you cannot multi-select them, you need to manually load each of them. Click on OK. Similarly, let's load the other 2 files. So now that we have loaded all the 3 source files, it's time we bring them to our Mapping Designer workspace. So go to the Mapping Designer workspace, select all the source files, drag them and drop them to the workspace. So you have all the 3 sources present here with their corresponding source qualifier. So now it's time we create a union transformation that helps us join all these 3 sources. So to do that, go to the Transformation tab, select on Create option, and here choose the Union Transformation option. Set the name for the Union Transformation and click on Create to create them. Now one thing you can notice here is that by default there are already 2 rows present in the union transformation. The first is denoting the output and the second is denoting the new groups. So here one thing to be kept in mind is that even if you select all the values from a source qualifier, you cannot drag and drop it directly to the union transformation. If you do that, a new group is created but it's not correctly added. So now you may be wondering how we can add the corresponding ports to the union transformation. Now first thing we need to do is that we need to create groups inside the union transformation. So let's go into the union transformation. Here if you go to the ports tab, you can see we cannot directly modify the ports associated to the transformation. So you can either manually create them or first make sure you have created 3 groups or n number of groups if you have n sources, and then correspondingly link them. Once you set this, click on apply and click on OK. So here you can see we have 3 sites, site 1, site 2 and site 3. Now if you wish, you can select all the columns from one transformation and then drag it and drop it to the union transformation. But as you can see, it's been disabled again. So as I had mentioned, you need to manually add these columns in the union transformation. So let's go into the union transformation. Here, go to the Groups Port tab. Here you need to manually add all the columns that are present in all the sources that you have loaded. Now one thing to be kept in mind while you're adding the ports is that you set the correct data type and the correct precision. So it's always helpful if you refer the source qualifier before you go ahead and create the ports manually. Let's go to the Groups Ports tab. Here let's add them one by one. The first is to add employee ID, which is of a type decimal. Let me set the precision to be 3. Then let's go forward and add all the corresponding columns. So now once you've added all the columns, make sure you have set the correct data type and the precision. So once you've specified the corresponding column names, the data types and precision, click on Add, click on Apply, and once you go back to the union transformation, you can see all these columns have been added across all the groups. So for each group we have the same set of columns present. Now one thing to notice guys is the first group is the output group. As you can see, only the output port has been enabled for this first group and the input port has been enabled for the corresponding 3 groups. So it's time we link the source qualifier to the union transformation. So just select all from the source qualifier, drag it and drop it to the corresponding site. Now any questions still here about the union transformation? About how you can create the groups or how you set the ports for each group? Any questions still here? So Ajay wants to know a scenario where union transformation is used. So Ajay, let's say you're using the same format to store the data, or you're using the same application to store the data in different locations. You have same data, same format but different data, and you wish to combine all this data, so you can use a union transformation to combine them. You can have any number of data as long as they have the same column names, same data types and same precision, then you can combine them using the union transformation. Was that clear? Alright, any more questions about the union transformation? So now let's move ahead and create a target definition to complete the mapping. So right click on the union transformation, select create and add target option. So as earlier, we need to rename the target definition and we need to create the target table in the database. So go back to the target designer workspace, clear all existing target definitions and just load the target definition that we have created. So go to the targets tab and select generate and execute SQL. Now if you wish to create your target table into a different database, just disconnect and select and specify and use the correct connection object to connect to your database. Click on generate and execute SQL and you will be asked for the connection object to your target table. So now as you can see, a target table has been created. Go back to the mapping designer workspace and let's create a workflow for this mapping. Right click on the workspace and select generate and generate a workflow. And finish. So make sure you save the mapping before you go ahead. Now the final step of completing the mapping is the linking of union transformation to the target definition. So just right click on the workspace and select auto link option. Here you can see we have multiple transformations. So inside the union transformation, make sure you have selected the output folder. So once you've selected that, click on apply, click on OK and save the mapping. So let's create a workflow for this. Right click on the mapping, select generate workflow option and proceed. So it's time we execute the workflow that we have just created. To do that, go back to the workflow manager. Here, disconnect from your work folder and reconnect. Now as you can see, automatically the new workflow has been added. So right click on it and select open option. So here let's check the session properties. Double click on the session icon, go to the mappings tab. So as I had mentioned earlier, if your source file is in different locations, please make sure you set the correct source directory. Also check if you are making use of the correct connection object. And with that, save the session, save the workflow, and then it's time to execute it. Right click on the workspace and select Start Workflow option. So you can see we have successfully executed the workflow. Now here, if you may notice, the three files have different number of rows. The first file has 20 rows, the second has 90, and the third has 168. But when you look at the final target table, it has a total of 286. That is the combination of all these three rows. So coming back, alright. Now to summarize, using the union transformations, we have just seen how you can join multiple sources, but they need to have the matching ports with the same data type and corresponding precision. Also, it does not remove duplicate rows. So if you wish, you can check if there is any duplicate rows present in it, but if you wish to remove it, you need to add another transformation which will remove it for you. And finally, you can create multiple input groups, but you have only one output group. And this output group is automatically defined by Informatica. Now, any questions about the union transformation? Sandeep says no, Dave says no. Alright. So till now we've seen three transformations through which we've joined multiple data. The first was the source qualifier transformation, the second was the joiner transformation, and the third was the union transformation. Now let's look at a transformation that's completely different from this. This is a passive transformation which is mainly used to perform row-wise operation. This is the expression transformation. Now as I've said, you use expression to perform row-wise calculation and compute certain expressional formulas. So one thing to be kept in mind is that the overall number of rows that pass through the expression transformation is the same, but the number of columns may vary. So here if you look at the image to your right, what we are trying to do here is that we are concatenating the first name and the last name, and then we are creating a new column in which these two have been concatenated, and we have single field for the employee name. Now through this operation, the number of rows does not change, but we have a new column that is added, but the overall number of columns has been reduced also by 1. So therefore the overall number of columns changes here, but the overall number of rows remains constant. Now another use of the expression transformation is to test conditional statements before you pass the data. Let's say if you wish to test a certain condition on the data that you are processing. So you can do that using an expression transformation. Let's say you need to make sure your profit for all the products is above 500. Then you can set the condition in the expression transformation and check if all the data meets this condition. So are we clear with respect to the expression transformation? So John says okay, Ajay says clear, Sandeep says okay. Alright. Now let us talk about a key feature that is provided to us through the expression transformation. This is the use of the variable port. Now mainly the variable port is used to store temporary values. However, it can be used to simplify complex values. Now when I say that, let me give you an example here for you to understand better. Let's say you wish to extract only the month from a date time field. So using the variable port, you can store the value of the month and then give it to further operations. Now apart from this, the variable port can also be used to compare the values present in different records. So let's say you have consecutive records and you wish to check the salary that is present for each of these employees. You can store the value of the salary from the first record into the variable port and then compare it with the second record. So are we clear with respect to how you make use of a variable port? So Matthew says clear, Dave is clear, Ajay is clear. Alright. So now let's move ahead and look at a use case where you will be using the expression transformation. So let's say as an organization, you're migrating your employee details from an existing file to a new database. However, you are aware there are certain inconsistencies in this data, so you wish to identify this before you migrate to the new database. So using an expression transformation, you can track these inconsistencies and then update them correspondingly. Let me show you how it's done. To do that, let's go back to the Informatica Power Center Designer. Let's begin by creating a new mapping. So once you've created the new mapping, go to Source Analyzer and clear all the existing source data. Before I load the source, let me show you how the source file looks like. So here you can see we have the employee ID, the first name, the last name, email ID, phone number, hire date, the job ID, salary, commission, manager ID, and the department ID. But if you may notice, there are certain fields that are empty. Let's say the email ID for Diana Lores, the last name for Louis, first name for Wise, and so forth. So what we need to do is that we need to check if there's any null present in either of these three columns. So let me show you how it's done using the expression transformation. So here let's begin by loading the source file. Now there's one change I'm doing with respect to the phone number is that I'm changing it to a text type rather than a number, because there is a special character present in the phone number, and this at times leads to the data following the special character not to be loaded. So it's suggested that you make use of a text format if your phone number has special characters. So now that our source is loaded, let's go back to the mapping designer workspace and load the source that we have just added. Now it's time we create an expression transformation. Again, go back to the transformation tab and click on create option. Here select the expression transformation and set a name for this transformation. Click on create and we're done. Now the first thing to do here is that make sure all the ports from the source qualifier are selected and linked to the expression transformation. Now once you've done with that, it's time we start editing the expression transformation. So let's go into the expression transformation. Here let's look at the ports tab. Now before I go ahead and I show you how you can identify inconsistencies, let me show you a simple use of the expression transformation. I'll show you how you can concatenate the first name and the last name. So first begin by adding a new port. Let's say name. Make sure the precision is greater than the combination of both of them since we are combining them. I'll set it as 30, and then here you need to uncheck the input port option. We're doing this because this value is not something that you get as an input, this is something that we compute. So immediately once you uncheck the input option, you can see the expression field has opened. So here we need to specify the expression through which this value is going to be computed. So click on the left arrow option and now let's define the formula. So here what do we have to do is that we need to concatenate the first name and the last name. So go to the ports tab and select the first name option, then specify the concatenation operator. Now to give it a good look, we'll add a space between the first name and the last name. Now the last name. You can again validate this formula that we have set. Click on validate and you can see the expression has passed successfully. Now this is not complete. We need to also uncheck the output option for the first name and the last name. Now we are doing this to ensure that the first name and the last name is not transferred from the expression transformation to the target database, because we are already computing a field which has the name of which has the concatenated first name and last name. Are we clear with this? How you can create an expression to concatenate the first name and the last name? So John says he's clear, Ajay is clear, Dave says he's clear, Sandeep is also clear. Alright. So now it's time we create the expression through which we'll identify the inconsistency present in the data. To do this, let's add a new column and let's call it inconsistency flag. So here what I'm going to do is that I'm going to create a flag that will help me identify which row has some inconsistencies. Once I've identified this, I can directly contact my employees and then update the required data. Now this is going to store only a flag value, so let it stay string. The precision would be 5. And now as I've mentioned, since it's a computed value, uncheck the input option and the expression tab opens automatically. So here we need to write an expression through which we are checking if the value for either the first name, the last name or the email is null. So all we need to do is that we need to make use of two operators here. First is the if operator, which will check the condition, and the second is null, which will directly check if the column value is equal to null. So first let's load the if condition, double click on the if option and it's added here. Now here we need to check if the first name or the last name or the email is null. So once you double click here, is null is added. Let's say we need to first check the first name, or if the last name is null, or the email is null. Now once this check is set, we need to specify the flag value that has to be set. If it's equal to null, let it be equal to y, else it is equal to n. Now that we have set the expression, let's validate it. As you can see, the expression has successfully passed. Now if you wish, you can also refine this expression to be better. So let's say there are null characters also present in your database which may seem as white spaces to the naked eye, but it may be occupying certain spaces. So those fields may pass this check. So what we're going to do is we're going to refine this even further. We'll first begin by removing the white spaces that are present in each of these fields and then check if they are directly equal to null. So let me show you the complete expression here. Now here, apart from the if and is null, we'll be making use of two different operators, that is the ltrim and the rtrim. Now these operators, what they do is that they remove the white spaces that are present to the left and the right of the string. Now if there is no value that is present in each column apart from white space, it will remove it directly and you can check if it is equal to null. So let me trim the values present in all the three columns. So first name equal to null, or left trim right trim of last name equal to null, or left trim right trim of email equal to null. Then set the flag as y. If not, check if it is equal to null. So let me explain this expression once again. What we're first doing is that we're removing the white spaces present in each of these values and then we're checking if it is equal to null. So if a field has only null present, automatically it will set the flag equal to y. Now even after removing the white spaces, we'll again check if it is equal to null. If yes, it is y, and if it passes this condition, then we'll set it as no. Are we clear on this formula? It's important that you understand this. It's based on this formula that you will be identifying the inconsistencies. So John is clear, Ajay is clear, Matthew is clear. Guys, please tell me if you want me to re-explain this formula again. It is important because based on this formula we'll identify if there's any inconsistencies in that row. Alright, so you can validate the expression and now we are set to go. So click on apply to apply all the changes to the expression transformation, and now let's go ahead and create a target definition. Right click on the expression transformation and select create and add target. Now all that remains is that we link the expression transformation to the target definition. Before we do that, let's just rename the target definition. Go back to the target designer workspace, clear all the existing target definition, drag and drop the definition that we have just created. You can check in the columns. We have only one field for the name, where we had initially two fields for the first name and the last name, but now we have concatenated and we are storing only one. So click on apply, click on OK, go back to the mapping designer workspace, clear the existing target definition and load the definition that we have just updated. The final step is to link the expression transformation to the target definition. Right click on the workspace and select auto link option. Click on apply, and with that we are set. Save the mapping and check whether your mapping is valid. As you can see, it is. Now it's time we create a workflow for this mapping. Right click on the workspace and select generate workflow option and finish. Now since this is an Oracle table that I'm going to be saving in my database, I need to create a table in my database as well. So go back to the target designer, select target option and generate and execute SQL option. So it's time we go into the Informatica workflow manager and execute the workflow that we have just created. So you can find the workflow that we have just created inside the workflow folder. Right click and select open option. Here if you want, you can check the session properties and make sure you're using the correct connection object. Save the workflow and it's time we execute the workflow. So you can see we have successfully executed the workflow. Double click on it. You can see we had 107 rows present in the source data and 107 have been transferred to the target table. So it's time we check whether the concatenation operation and identification of inconsistencies has been done. So go into your target database and here check the details stored inside the target table. So you can see here the name field has been concatenated, the first name and the last name has been concatenated with a space between them, and also an inconsistency flag has been set. So let me show you the data with inconsistency flag as Y. So you can see here, if you look at Diana Lores, her email ID is null, therefore the inconsistency flag has been set as Y. Similarly, we have 16 records that have some inconsistencies, so we can contact the employees and update the required details. Now to summarize, using the expression transformation, you can perform row level calculations as we've seen. You can also modify individual columns that are present in the row. So I've shown you how you can create a new column that has the name, which is a concatenation of the first name and the last name. So any questions with respect to the expression transformation? So Sandeep says no, John says no, Matthew says no, Dave says no. Alright, it's great to see that you guys are following. Now the final transformation we'll be seeing as part of today's session is the normalizer transformation. Now the normalizer transformation, as the name suggests, helps you in converting the data to a normalized format. Now when I say a normalized format, as I had given you an example earlier, let's say you have a customer details where the customer has given us 3 addresses, so you can create a row with the details of the customer where each address is unique. Similarly, if you look at the image here, we have 4 occurrences of the weekly sales, and we'll have each row with one corresponding value for the weekly sales once we normalize this. But one thing to remember is that if you're using the normalizer transformation, you need to be aware on the maximum number of which this multiple occurring instance will happen. So let's say if you wish to normalize the address field, address column, then you need to know how many times the address column is going to come. Now generally a question that is asked with respect to normalizer transformation is that how do you use normalizer transformations for COBOL file? Now by default, if a source qualifier is created for a COBOL file, then this is also a normalizer transformation. So Informatica automatically creates a normalizer transformation as a source qualifier for a COBOL source file. So remember that when you're going for an interview, it is something that is oftenly asked. So any questions about the normalizer transformation? Matthew says no, Ajay says no, John says no, Dave says clear. Alright. So now let's move ahead and look at an additional feature that is provided to us through the normalizer transformation. So this is the normalizer generated key and generated column ID. Now the generated key is just a key sequence number that is added to each row, and it gets updated every time we encounter a row. So let's say you have 100 rows, then you have a value for the generated key ranging from 1 to 100. However, it is important that you remember this generated key gets updated every time that you execute it. So let's say if you restart a workflow the second time, the generated key value will start from 101 instead of 1. This also helps us to set that the generated key be a primary key value in the target table. If there's no primary key already present in the target table, then you can make use of the generated key to be as the primary key for that table. After that, we have the generated column ID. Now the use of the generated column ID is just to help us understand which instance does this belong to of the multiple occurring field. Since you have 3 address fields, the generated column ID will be 1, 2 and 3. So you can identify whether this is the first instance, this is second instance or the third instance. Are we clear with respect to the generated key and the generated column ID? Any questions with respect to these? So Janice is asking us if we can reset the generated key. Definitely, Janice. Now inside the properties of the normalizer transformation, we have an option where we can reset the value for the generated key so that it starts from 1 every time the workflow is executed. Any other questions? Alright. So now let's move ahead and look at a use case that involves normalizer transformation. Now we all have 2 contact numbers these days. So similarly, in my employee database, each of my employee has 2 contact numbers. One is his official and the second is his personal. Now I need to update my employee database in such a way that each employee has only one contact number with his corresponding field. So using a normalizer transformation, we can achieve this. So you can see the source data looks like this, where Anmol Tripathi has two contact numbers, same with Smita Deshmukh, but after normalizer transformation, we want it to be Anmol Tripathi with just one contact number. So employee name with his contact number, and and each contact number is a unique value. So let me show you how it's done. Go back to the Informatica Power Center Designer. Here, begin by creating a new mapping. Now let's load the source data. So I've stored my details of employee in a CSV file. Go back to the mapping designer and bring in the source that we have just loaded. Now at any point, if you wish to check the data that is present inside the source definition, just right click on the source. Now if you wish to see the data that is present inside the source definition, just right click on the source definition and click on preview data. So in case if your file is present in a database, just set the database and the username. In case if it's a flat file, just select the flat file name. If you click on open, you can see all the data that is stored inside the file. So you can see we have the employee ID, we have the employee name, their email ID and two contact numbers. So now let's add a normalizer transformation. Go to the transformations tab and select create option. Choose normalizer and set a name for normalizer transformation. Click on create and we are done. Now one thing you need to remember with the normalizer transformation is that you cannot drag and drop all the values from a corresponding transformation. Once you try to do that, you can see a notification below that says cannot copy a column to this transformation. So in the normalizer transformation, you cannot add a column directly. You need to manually add the columns to it. To do that, let's go into the normalizer transformation. If you go to the ports tab, you can see all the options to add or delete ports have been disabled because Informatica will automatically generate the ports for the normalizer transformation. Go to the normalizer tab. Here you can add the columns that you wish the normalizer transformation to have. Click on create. Let's begin with the employee ID. Now this is why it is important that you understand the occurrence, the maximum occurrence of each of the columns, because you need to specify the number of occurrence of these columns, else you cannot go ahead with your mapping. So Dave has a question here. What do we do in case we do not know the maximum occurrence? So Dave, in those cases, it's generally suggested that you make use of a Java transformation to process your data, because it's very important in normalizer transformation to know the maximum occurrence of the data. Similarly, add all the other columns. Now we have two contact numbers, but we're going to add only one column name for contact number. And then we're going to set the occurrence to be 2. So I have loaded my contact number as a string because they were special characters. So if you've loaded them as string as well, make sure you set the correct data type. So once you specified the column names, if you click on apply and go to the ports tab, you can see Informatica has automatically created the ports based on the column names that you have specified. None of these are editable, so do not try to play around with them. Now if you notice, we have two copies of the same columns that we have specified. One is for the inputs. As you can see, their input ports have been checked, and one is for the output. Now apart from the column names that we have specified, we have two new columns. One is the GK contact number and the second is GCID contact number. So as I had mentioned, these are two features that Informatica provides us to help us understand this data better. So click on OK, and now you can try to link the source qualifier to the normalizer transformation. Any questions still here with respect to the normalizer transformation? So Ajay is clear, John is clear, Janice says no. Alright, so now to go ahead, we need to create the target definition. Right click on the normalizer transformation and select create and add target. Once you've done this, we need to modify the target definition. Go back to the target analyzer workspace, clear all the existing target definition, and load the target definition that we have just created. So let me show you how you can set the generated key as a primary key. So go into the target definition, and if you go to the columns tab, here you can see we have an option that is key type. So if you wish to set the generated key as a primary key, just click on it and select primary key option. So now when you're creating a target database or a target file, it will automatically consider the generated key to be a primary file. So let me make it a flat file instead of an Oracle database file. Let's go back to the target designer workspace and load the updated target definition. Here let's connect the target definition to the normalizer transformation. Right click on the workspace and select auto link option. So you can see the first few columns are the input columns, and then we have the output columns. So save this mapping. As you can see, the mapping is valid, and then let's create a workflow for this. Let's go to the workflow manager. Here disconnect from your working folder and reconnect. Inside the workflow, you can see the workflow that we have just created. Right click on it and select open option. So since we are writing a flat file, we need to set the header and the extension correct. Click on apply and let's save this. So now that we have saved our workflow, it's time we execute this. Right click on the workspace and select start workflow option. So you can see we have successfully executed the workflow. So if you look at the statistics of the source and target, you can see our source had 800 rows, but our target now has 1600 rows. So since we had 2 contact numbers, it has been doubled. So let's say if you had 3 contact numbers, it would have tripled and we would have had 2400 rows. Let me show you how the generated key value works. Before that, let's look at the target file. So you can see the generated column ID only varies from 1 and 2. However, the generated contact number starts from 1 and goes on all the way till 1600. So let me show you what happens if I re-execute this. Let me just rerun this workflow. Just right click on the workflow and select restart. And now if you look at the target file, you can see the generated key for the contact number has started now from 1601 instead of 1. So are we clear on this, how the generated contact key works? Any questions with respect to the normalizer transformation? Sandeep says no, Dave says no, Janice says no. Alright. So to summarize, using the normalizer transformations, we can convert multiple occurring data to single unique data. We've just seen how it's done, and you can use the generated key as a primary key. Because this is a unique value that does not repeat, you can set it as a primary key in your target definition. So with this, we come to a conclusion of today's session. If you have any questions with respect to any of the transformations, please do let me know. We can clarify it. Else, make sure you provide the feedback after the session. If you want more information about Informatica transformations, you can check out our blog, Informatica Transformation, the heart and soul of Informatica Power Center. So any questions, guys? Janice says no, Sandeep says no, Ajay says no. Alright, thank you for being part of today's session. Hope you have a great day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!